problem that links acceleration to forces and friction. It goes like this. While decorating her apartment, Julie pushes a 490 Newton dresser across the floor by applying a 500 Newton horizontal force. The coefficient of friction between the dresser and the floor is 0.612. Determine the acceleration of the dresser. So as always, we need a picture before we worry about numbers and problem solving, just to see what's going on. So let's see, there's the floor, obviously. There's a dresser. My dresser at home has a weird decorative top, so I'll try and approximate that. Like this. It's got like this really cute thing. Yeah, it looks about right. There's the dresser. And then Julie worked real hard to push it and not just move it, but actually accelerate it and presumably speed it up, probably from rest. There's Julie pushing the dresser. So that's what's actually happening. We're worried about the dresser. That's our object in question. It obviously has lots of forces, so we're probably going to draw a free body diagram, draw a picture of all the forces acting on this dresser. So I'm going to let this dot right here represent this dresser and just draw vectors to show which way the forces act and their relative sizes. Obviously, Julie's pushing it forward, so there's definitely a forward force and applied force. And I'll draw that this way. So this is the force applied by Julie, and it is forward 500 newtons. No, how hard is Julie pushing? Where is it? Oh, yeah, it's 500 newtons. That's the forward force. If that was the only force, it'd be a one-step problem. That'd be also the net force we could solve for acceleration. But it's clearly not the only force. If we look at this dresser, there's more than just Julie that touches it. There's the floor touching on it. We can expect that there's a supporting force there, that there's some friction generated there. There's also planet Earth nearby, so gravity's going to act on this. So let's start with gravity. That's downward. Do we know how big it is? In this case, we're actually given the force of gravity. It's given the weight in newtons, not the mass, so we know how big it is. It's downward. 490 newtons. The floor is supporting it. It's pushing the dresser upward. There's presumably no vertical acceleration, so you can assume that that support force, that normal force, is the same size as force of gravity. Since there aren't any other vertical forces, and the vertical forces must balance in this case. And then the last force that there is the force of friction. That's not a known value, but we can presumably solve for it. It's going to be opposite the direction that that dresser is about to accelerate. There's a backward force of friction. And we'll try and figure out just how big that is. So right now that's unknown. Those are all the forces that act on this dresser. So we can start looking at how we're going to solve this problem now. We're obviously going to need to know how big the force of friction is so that we can find the net force, because net force is what's going to link to acceleration, and that's in the end what we're looking for. So let's start by trying to solve for the force of friction. Force of friction depends on two things. It depends on coefficient of friction, which kind of tells you how sticky those two surfaces are together. It depends on how much those two surfaces are pressed together, which is really the normal force. And since both coefficient of friction and normal force are known in this case, we can solve for force of friction. Coefficient of friction is 0.612. Normal force is 490 newtons. And so the force of friction ends up being 300 newtons. And I'll just add that to my picture right now. Got the force of friction. So at this point, all the forces in our picture are known, and we can look for the net force. Vertically, you can see right away there is no net force. Up force and down force balance. But horizontally, there will be a net force. Net force is the sum of the forces. And so let's sum the horizontal forces. There's a rightward applied force of 500 newtons. And there's a leftward, so we'll call that negative 300 newton force. So that total horizontal force is 200 newtons. Because there's friction, it's going to accelerate a lot less than you might expect from that 500 newton force, because that friction kind of reduces the effect, brings down that net force. And now we would normally be one step away from solving for the acceleration, because acceleration is net force over mass. So all we have to do is divide by the mass, but the mass actually isn't what's given in this problem. You're given the force of gravity. 2 more steps to go. From the force of gravity, you can easily solve for the mass, and then once you have the mass, you can easily solve for the